So I changed DBs again. I know, I need to stop doing this, but I saw all of the comments. Everybody's been telling me forever I need to just use Postgres. So you know what? It's time. I finally decided we are going to move all of our infrastructure over to Postgres. I know this is kind of crazy. You're all surprised about this. I am not a big Postgres fan, but I am a fan of one particular thing in the database scene. You probably already know about it. PlanetScale. I love them so much. They make databases much easier to work with, much faster, and they scale incredibly well. I was really sad when I had to move off of PlanetScale because I needed a better synchronization engine for managing all of the stuff going on in T3 chat. So your chats would be in the right place at the right time, and they would sync between devices and all these other complex features. That move was sad for me because it meant that we were moving away from the thing I love, know, and trust so much, PlanetScale. So I did what any person with a lot of connections would do. I tried to force those two to kiss. I went out of my way to try and push Convex and PlanetScale to start talking. And then something weird happened. PlanetScale announced PlanetScale for Postgres. Yeah, I did not see this one coming. I don't know if anyone saw this one coming. But part of the announcement, as with all announcements from PlanetScale, is that this isn't just a thing we're putting out. This is a thing that's already being used. When PlanetScale dropped Metal earlier this year, they announced it alongside all of the people who were already using it at that time, including companies like T3 Chat, companies like Square, and many, many more. They did that again here, but the company they announced it with is very interesting. Convex has made the move. This is a wild change for a bunch of reasons, from the performance gap between PlanetScale and everybody else in the Postgres scene, to the shift away from MySQL and Vitess as their end-all be-all solution, to the fact that I'm now technically using Postgres again. I never thought I would see the day, but here we are. There's a ton to talk about here. I can't wait to do it. And even though these companies do pay me sometimes, they're not paying me for this, and someone's got to cover the bill. So a quick word from today's sponsor, and then we'll dive right in. You'd think in the era of AI that integrations like authentication would be way easier, but I've actually found it to be the opposite. Now they have to worry about all these new types of sophisticated bot attacks, all of these different services you have to auth with, and all the different companies that want to try out your stuff. Getting auth right has never been harder, as frustrating as that is. That is, unless you use today's sponsor, WorkOS. These guys get it. They've really figured out auth, both on the enterprise side, so businesses can adopt your thing, but also on the developer side, so you full-stack TypeScript folks are going to have a great time integrating it. You've probably already seen their auth flow on things like Cursor, OpenAI, Vercel, Plaid, Carta, Fal, SourceGraph, Replit, and all of the other companies that are in this whole world. I feel like it's more often that I see the WorkOS sign-in than I don't nowadays. And there's a reason for it. They understand what we need as devs and what companies need to integrate. I've been a little bit embarrassed about how many clients I've had to turn down for stuff like T3 Chat because we just didn't have the stuff set up properly because I made the mistake of rolling my own auth. We've been planning a move to WorkOS for a bit, and the reason why is pretty apparent when you read these testimonials. This comes from Warp, the AI terminal. The onboarding process has been excellent. I love sending IT admins the link to set it up themselves and getting an email notification when it's completed. It's so efficient not having to go into meetings or go back and forth via email with IT personnel. I've had to do this. It's not fun. I wouldn't wish it on my worst enemy. So if you want to avoid all the hassle and get auth right first try, check them out today at soidev.link/workos. I think the best place to start, as we do with almost every rant about Postgres, is one about MySQL. Why did PlanetScale bet so hard on MySQL? The truth is they didn't. While they did use MySQL very heavily, and that is the thing that most of us use PlanetScale for, MySQL was not the technology that they bet on. The technology they bet on is a tech called Vitess. The best I can simply put it is imagine Kubernetes for your database. It is a way to automatically split, fragment, and distribute and shard your database so that your MySQL DB can scale way better. It was originally built at YouTube in order to make their database layer scale. The people who built it went to GitHub, made the almost exact same thing there, and they realized, oh, this is a service, we should probably sell this, and then they formed PlanetScale. PlanetScale is a company built around the scalability of Vitess, making a simple, reliable, third-party solution that you can use as your database engine for everything. Vitess is the key to a lot of what PlanetScale did, and it's a huge part of how they got where they are today. So the reason they picked MySQL is the strength of Vitess and the generally more composable nature of MySQL, where like the pieces of MySQL are more separated internally, so it's easier to change out parts, to swap out parts, to integrate around it. Postgres is much more tightly bound. All the parts kind of come together. And yes, I see chat saying how confusing it is. There's Vite, Vitest, in Vitesse. There's also Vitesse with an E at the end, which is a docs generator. Yeah, this is from Antfu. So you got a lot of Vitesses, but we're talking about the database Vitesse right now. So hopefully that helps answer why MySQL. It's the thing that they built all of this tech around. So question 2 then, based on this being Vitesse, would obviously be, how'd they make Postgres so fast? Did they build a new Vitesse type thing for Postgres? They're working on that. Funny enough, the PlanetScale co-founder also left and is now at Supabase doing the same thing. Neither have made much progress as far as I've seen. In fact, the open source repo that Supabase put up for their Vitesse Postgres thing is just a README right now. So how did PlanetScale make their Postgres layer so fast? This actually comes down to a change that they made earlier this year that I hinted at a bit before. And it also has to do with the shirt that I am wearing underneath this nice fancy collared shirt. IOPS. What the hell are we talking about with IOPS? It's I/O. What does I/O have to do with any of this? Well, you gamers will love this part, because one of the big things PlanetScale did is they moved everything over to using local NVMe drives. This is key. These local NVMe drives are PCI based, which means that they are effectively going straight to the CPU, skipping a ton of steps, drastically lowering latency, drastically speeding things up. It's pretty nuts how much faster things can be if you use NVMe drives on the machines that are actually doing the CPU work. Well, why isn't everybody doing this? The harsh reality is that most places separate the storage from the compute. So you have these compute pieces, like these random servers. So I'll just name them CPU 1, CPU 2, CPU 3, etc. And then you have a big storage blob in the back. And this is where all of these things get their input and output from. So if you send a query to your server, it goes to the CPU. CPU via network connects to a persistent storage. So something like S3. It's usually not S3, but it's something like that where you have something that is a resilient storage layer. Why would you do that though? Why wouldn't you just use whatever storage is attached to the computer that has that CPU on it? This is part of both the benefit and the cost of using something like AWS. At any time, any one of these nodes can die. You never know if or when that's going to happen. That sucks. That sucks really, really hard. Because if you store something in one of these and it hasn't been shared with the other machines yet, and then it dies, that data's gone forever. And that is not fun at all. They actually have a really fun blog post about this by Benjamin that I've been meaning to make a video about for a while, of how fast different storage solutions are and how many nanoseconds it takes to do a read or a write on these different devices. The key about this is volatile and non-volatile storage. Things that are in your CPU registers, cache, or even RAM are all volatile and it could disappear at any point. Non-volatile storage is your disk. The problem is that, again, you never know on a service like AWS when one of your boxes is going to die. So putting your storage there would just break constantly. What if I told you that PlanetScale was built to let things break constantly? What if I told you that the Vitesse layer they built up here at the top was built under the worst possible conditions for servers, so that they had to build it in a way where if one node goes down, everything else is fine? What if I told you that every database on PlanetScale was created within the last 30 days? And if a database gets older than that, they kill it and reset it. That's the magic of PlanetScale, is you don't have one database, you have a bunch of them. Here's our old PlanetScale dashboard for the previous T3 Chat DB. This DB was the one powering sync for T3 Chat. As I've mentioned many times now, we moved to Convex, and I've missed working with these guys a lot. And you can see how magical this is. We have our primary, which is our main DB. It's what most traffic goes to and gets hit for. It replicates to 2 additional boxes. So at any given time, this can fail and one of the replicas comes online instead. That's awesome, because now at any given time, any one of these boxes dying is not a problem. It just auto routes to the next box immediately. It's magic. It's super, super useful, especially if you're at a massive scale where errors can happen or you have lots of different boxes and one can fail at any given time. This allows for a box failing to not kill your service, to not kill queries, to not even kill an active write. It's pretty nuts what their VT-gate layer can do because Vitesse is so powerful. Because of that, PlanetScale was able to move the storage to be in these nodes by literally just plugging an NVMe drive into them and shipping the servers to AWS to install for them in the same zones. And now you have databases that can write and read data comically faster. And if one fails, it's fine. It just rolls over to the next one. That's the magic of Metal, is there's no longer this external storage layer that you have to rely on. Each of these boxes has their own way, way, way faster storage, which means you have unlimited I/O at way faster speeds. So to go back to the question of how do they make Postgres so fast? They took Postgres and they put it on these boxes. It comes down to that. They haven't built much in terms of special Postgres hacks or things around the Postgres data layer. They just plugged it into their existing infra. Let's compare to some well-regarded databases. We got Aurora, Alloy, Lakebase/Neon, Supabase, Heroku, Crunchy Data, and Tiger Data. Let's start with everybody's favorite, Neon. Probably the most immediate comparable solution in terms of like Postgres auto-scaling across many nodes and replication. So the Planet Scale instance that they're comparing against with has 4 vCPUs, 32 gigs of RAM, about a terabyte of storage, and unlimited I/O. Neon has to have 8 virtual CPUs because that was the only way they could get a comparable amount of RAM. Storage auto scales, and I/O is not available. So let's see how they benched. This is queries per second with 64 connections. That's a pretty big gap. It's a consistent 50% win for Planet Scale. That's pretty big, but like, we have to see how big the cost difference is, right? Okay, I know, guys, it's EBS, not S3. Not everybody knows what EBS is, so I wanted to put S3. And some databases do use S3 as their backing, sadly enough. But anyways, yeah. So Neon, in some of these spikes in this next section for milliseconds of latency, some queries are taking like a second. Okay, this is their latency for the duration of the benchmark. Yeah, sometimes it's hitting like up to a second of latency. Planet Scale never breaks 400 milliseconds, except for this one tiny spike there. And even then, it's barely. And this is an intense benchmark. They have all the details for it on their site, if you're curious. Oh boy, queries per second. Again, pretty big gap. P99 latency, one of my favorite numbers. This is how bad is the latency in the worst 1% of the time. And you can see a lot of really nasty looking spikes for Lakebed and Neon. Literally 5 to 6 times worse than Planet Scale's pretty flat 50 milliseconds. Here's a fun test where they just run select one over and over again 200 times on one connection. And man, you never know how long a query is going to take on Neon. Kind of nuts that it can go up to 5.5 seconds to select one 200 times. Oh God. Are these all microseconds? Oh, it's microseconds. I thought it was milliseconds. My bad. Okay, so that's not 5.5 seconds. Thank you for the correction, guys. Still insane though. So the cost must be way worse, right? Yeah. $4,000 a month for the Planet Scale instance and over $3,000 a month for the instance over at Neon. But Aurora is really good, right? Aurora's Amazon's scalable solution for doing Postgres in the cloud. Let's see how it compares there. Oh, look at that. Still about a 50% increase in queries per second. Oh, look at that. Almost 3 times better latency. Planet Scale actually looks a tiny, tiny bit worse on the select one over one connection, but like barely. And this is within cost range, but still cheaper. $1,400 a month for Planet Scale and $1,800 a month for Aurora. So depending on what you're doing, it's either a little better or a lot better. Pretty nuts. How about Supabase? Oh God. Oh God. I don't have that much against Supabase, but I've seen some really scary issues with it. In particular, I've seen some really rough performance issues at scale, especially with a lot of connections. But man, ow. Ow. Jesus Christ. Yeah. And it's still cheaper. The 2x large Supabase instance is $44, $94 a month for the 750 gigs of EBS, $216 to upgrade to 12,000 IOPS, $2,100 a month versus, again, $1,400 a month. God fucking damn it. That's terrifying. And then everyone's favorite, Heroku. God, Heroku was the last Postgres database I deployed that I actually tried to use. And it's a big part of why I got into Planet Scale. Fun fact is that when I was first building Ping, back when it was still called round.t3.gg, not round, it's not the Pokemon voting thing, the video call app that I built. Heroku was the database I started with because it's what I knew. And I was doing backend for the first time in a while. And it didn't go great. And I'm sure that these numbers will confirm how bad it went. Jesus fucking Christ. Literally 16 to 20 times faster. 1,000 QPS versus 18,000 QPS. Terrifying spikes as things go on. And what's funny here is the default is 32 connections on Heroku versus 64 on Planet Scale. God, that's even worse. The 64 connections. Jesus Christ. This one's in milliseconds, not microseconds. Okay. Sometimes you get 21 seconds of latency on Heroku. Obviously, Heroku is really cheap, right? That's why we all use it. $22.50 a month versus $1,400 a month. Okay, we get it. Those are the benchmarks. But how does it actually perform for people? What does it actually look like? As mentioned before, Convex made the move. We'll talk about why in a little bit. But I want to show you the numbers they have been sharing since they made that move. They built Chef, which is their AI app builder that I kind of bullied them into making. This is a hilarious drop. They were previously on Aurora with MySQL, and they made the switch to Postgres on Planet Scale. First off, insane to switch from MySQL to Postgres, like on the fly the way they did. But yeah, pretty nuts. Pretty insane to see these differences in the real world. They also migrated us, as I mentioned before. And here's what some of our latency differences look like. There are different things that have changed different amounts, and I actually went out of my way to spend some time in the Axiom dashboard to see the difference here. The switch happened around here, which is why we had these weird spikes. This is for adding a message to the thread, so the write that somebody does before they generate a new message. The P99.9 hovered between 100 to like 180 milliseconds. Sometimes it would drop a little lower, but it was usually a bit over 100 for the P99. Since the change and an outage that we'll talk about in a bit, it's now down to 20 to 40 milliseconds for the P99.9. That's a huge drop. That's a like 5x decrease. Pretty nuts. Not all things were immediately better though. If I switch to the getter, the get thread by ID, I have to switch this to be, I'm going to do 2 days so I have enough data. Also, God bless Axiom for making something this good for checking these things. Here we could see that the P99 was around 250 milliseconds, P99.9 that is. And now it's a bit lower. Initially, it was actually a little higher. Specifically, the P99 went from 70 to 100, but it's since stabilized quite a bit. Now we're in the like 50 to 60 range. It's gotten quite a bit better. And thankfully, the P50 has stayed really solid. So the reads have not been as big a win for us. In fact, it was slightly worse initially. Very slightly, but it was slightly worse. And now it's significantly better. The writes are the real magic. And now we have the obvious question that I'm sure a lot of you are asking. Why did they not just switch to normal Planet Scale MySQL? Thank you, Ethan, Mr. Effect here, for asking an important question. Why didn't Convex use MySQL on Planet Scale? They were already a MySQL company. They were already using it heavily. They played other stuff a ton. But what was it that made them pick Postgres? The answer is silly, but hear me out. It'll make more sense in a bit. It's just Postgres. I know you're looking at me like, what the hell do I mean about this? Postgres is a standard. It's a standard a lot of people are used to, a lot of people use, a lot of people do stuff with. MySQL on Vitesse on Planet Scale, it is MySQL, but it is a very much managed MySQL. So you spin up 1 DB per instance. That DB can be replicated, as I was showing before, where we have this primary DB replicated in other places. But I couldn't really spin up a second one here because the abstraction layer is too high. This gate is dedicated to 1 instance of MySQL. That means that if I'm paying for a server of a certain size, I can only use it for 1 DB. There are a lot of hacks and things you can do to get around the issues that are inherent to this. For example, we put prefixes on all of our tables so we could use 1 DB for multiple projects or multiple different things at the same time. But there's a really cool thing you can do with the way they implemented Postgres. You get a multiple DBs per instance. Do you see why that would be useful for a company like Convex? Planet Scale doesn't have a free tier. Planet Scale charges quite a bit of money. Their cheapest tier is like $30 a month. And all of the metal stuff that they're doing, that's a lot more expensive. Using metal on Planet Scale is $600 a month minimum to just get started with metal. And there's no way they can give that out for free. Because Planet Scale would dedicate the infra, the instance, all of that to you, there wasn't really a multi-tenancy story for yourself or for their customers where you couldn't use metal on a cheaper tier because the database just didn't work that way. And this is why the Postgres move works really well for Convex, enough so that it makes sense for them to make a change that I never thought I would see them do. One of the reasons I like Convex so much is they knew databases well enough to know that MySQL was a really good solution. And if you're wondering about Planet Scale reintroducing the free tier because of this, Sam had a really funny tweet to reply here. We intend to stay the only profitable Postgres provider as well as the only fast one. Sam's having a lot of fun with this. Want to read a bit more about how Convex's move went because it's really cool and I haven't actually read this article much yet. When developers choose Convex, they're often betting their company on our infra. Yep, I've been burned by this, but I've also benefited a lot from it. Sorry for the recent outages. We'll stop changing databases soon, I promise. Fate had to push me to Postgres. So yeah, to everybody who's been complaining that I'm not using Postgres or taking it seriously, here you go. We're doing it now. Stop complaining about the outage. It was a quick one. We're good now. But if it happens again, we will be going back. Anyways, responsibility we take seriously, and fulfilling it begins with having a world-class relational database as our foundation. The database service that underlies Convex must be rock solid, extremely fast, and cost efficient. For years, we've operated Convex on top of AWS Aurora. The experience has been okay. Aurora does what it says on the tin. It's reliable, it scales reasonably well, it integrates nicely with the rest of AWS. But okay isn't where we want to stop. When PlanetScale released Metal this year, we were honestly pretty jealous. The performance numbers they were showing off were incredible. We knew how deeply the PlanetScale team understands database services, and they were literally the only team we trusted enough to consider leaving behind Aurora. So we started wondering, what would it look like to build Convex on top of PlanetScale? A couple months ago, we reached out to the team at PlanetScale to explore the idea. We discovered they were working on something new, something perfect for the future of Convex Cloud, PlanetScale for Postgres. And of course, Convex is a PlanetScale for Postgres launch partner. They've started rolling it out. Performance gains are incredible. If I recall, all new projects on Convex now are going to the PlanetScale instances. When they moved over, latency got hilariously better, in particular, commit latency for actually doing writes. Significant improvements, especially the P99. Yeah, P50 is the new P99. Yeah, the latency they had for their 50% worst is now the latency they have for their 99th percentile. Kind of nuts. If every new Convex project runs on PlanetScale, your app will be blazing fast with room to scale as far as your ambitions take you. So the quote I've seen from a lot of people is, oh, so Convex is basically just Postgres with sprinkles? In the same sense that a Google Pixel is basically Linux with sprinkles? Sure. James actually published a really useful diagram of how Convex works that I think will help emphasize what layer the database is. It's literally just this part here. So they swapped out this one node, this Aurora node, with PlanetScale, and everything else is still the same. That's part of what makes Convex so magical, is all of these pieces that they've built here for you are things you would normally have to deal with yourself that they just did so you can build a good experience for your users and for your team of developers. Really cool diagram. I'm going to save this for my Convex video in the near future because I really just need to rant about all the things that Convex is good at some point because I, again, was really skeptical and now I am all in on it. So I want to give one more example of how hard the Convex guys are working. Again, they switched everything over to Postgres as part of this. And there were a couple little things that I showed in terms of like the read speeds being slightly worse after the migration, where we went from a P50 of 15 to a P50 of like, the P50 is about the same, but the P99 went from about 90 to about 112 to 120. And the P99.9 got slightly worse too. I showed these numbers to them. They were a little scared when they saw it. They went and hacked and looked deeply into it. And they came back with a bunch of changes to code that just, I don't even want to process this code in my head. Every time I read both Rust code and complex like data layer code, my brain feels like it's falling out. Yeah. See this shit? I am so happy I don't have to write stuff like this. You guys have no idea. Very thankful that the Convex team is writing this insane layer in Rust to make sure the data is as fast and reliable as possible so I don't have to deal with any of this shit. Also of note, I can do this because Convex is fully open source. So if you want to self-host it on your own MySQL or Postgres instances, you can do that. Feel free. They even have guides on how to do it. They're not the like, it's open source, but hosting it sucks. They have that all ready to go. I've never done it because I don't care. I'd rather just use the cloud option, but it's an option for those who are interested. One last breakdown here from Indrajit. Hopefully I got your name right, from over at Convex. He did his best to break down why Postgres is so much better on PlanetScale than it is other places, breaking your brain on how they thought Convex worked in particular. So let's do it. Most of us think of databases as black boxes. It's very convenient, but if you peek into the box, it's just another system with different layers and subsystems. These subsystems can be roughly described as the following three parts. The query engine, which is the thing that interprets SQL and turns it into real instructions to retrieve data. Part two is the schema and relational model, which is how data is virtually organized and operated upon. Then part three is the storage layer, which is how data is persisted to and organized on disk or across different boxes for a distributed DB. Convex replaces 1 and 2, and the stuff that sits a couple of layers above it for building apps, but it doesn't need to innovate on 3. So for 3, we're switching to PlanetScale. Yep, that's what they're doing. People seem to think that the database is just this thing, but the what is a database spectrum is pretty nuts. Similar to like what is a full stack dev to an extent. Most people think this is the database. So when they look at Convex, they assume it's just that. Convex is really focused on everything else. This part's boring. In fact, this part just gives them trouble sometimes. Like the query planner from Postgres is part of why we've had latency issues, because Postgres thinks it's smart, tries to do something to make it faster, and is just wrong about it. So most of the work they're doing is how do they opt out of all the query planning bullshit that Postgres does by default in order to make it faster. PlanetScale just focus on making the input output as fast as possible and distributing that database as reliably as possible. So failures and edge cases and all those things just go away. Convex is trying to make it easier to work with, easier to do right, and nicer to ship to your users and keep everything in sync. That's how the two relate. And it makes so much sense that they are getting as close as they are now. It's almost like the perfect partner, where something like Supabase has decided that they're going to build all of this themselves. And as a result, it has everything you need. But at the same time, I feel like when using Supabase, any one part is lackluster. And there are parts of Convex that are lackluster. Like their auth stuff is not good. There's a reason they push you to go use Clerk and other things. They had to build an auth layer because they were trying to build everything and make it all integrate nice. But if you are building everything, some things are lacking. The thing I like about Convex is they choose where to stop, and they've chosen to stop at the database layer. And that's why PlanetScale makes such a good option for them. And the best part is that now PlanetScale does have a free tier. That free tier is Convex. What a journey this one has been. I still can't believe that I am back on Postgres after years of avoiding it, after nearly a decade of avoiding it at this point. But the reason I'm there is that I don't need to think about it. The engine that is powering where my data comes from is not something I really have to think about anymore. It's fun to, but I have no reason to. So if you want to make your data go as fast as possible, you should probably check out the new PlanetScale stuff. And if you just want something that's convenient to use for your apps, I highly recommend Convex. I've been having a great time with it. Curious how y'all feel about it, though. Thank you as always, and until next time, peace, nerds.